Alright, Yuri says welcome back for the next video. We got two, maybe three videos on seasons in the sun, and we picked a perfect, not at all sunny, nice dreary, rainy day to go for this one. Yuri made, I think we got 4 drawings here. So we're going to focus on diagrams of the sun and the earth and picking out what season it is and how we know what seasons we're looking at based off of the diagram. So there's a couple key things to keep an eye out for. This first drawing, very well done drawing from Yuri. So we're always going to have a bunch of dates on here, and those 4 dates, they have to be in your brain. So there's not much reference table stuff with the seasons, and that's why there's a few extra videos, because everything is pretty much looking at diagrams, memorizing some key dates. Technically, it's not always the 21st on these different months for the dates, but we're going to always use the 21st. On the Regents exam, the 21st will always get you the answer if you use that for a number. So you've got March 21st is the spring equinox, and then the summer equinox, summer solstice, first day of summer is June 21st, and then September 21st, first day of fall equinox, winter solstice, first day of winter, December 21st. So there's different characteristics of the sun each of those days. But those are the 4 key dates. Now looking at diagrams, you're either going to have side views or top views. So looking at from the side is more common. It's kind of what's naturally drawn by people. The key things that you're looking for, where is the sun and where is the North Pole? The North Pole here isn't tilted towards or away. It's not pointing towards the sun, not pointing away. That's why you've got the equinoxes. The dark part, that dark light line, goes right through the North Pole, South Pole. June 21st, the Earth, the northern hemisphere is tipped towards the sun. So June 21st, strongest sun, longest days for the northern hemisphere. December 21st is the exact opposite, tipped away. Okay, that's our winter. Now, everything in the southern hemisphere is opposite. Australia is always going to be opposite. Okay, but you got to memorize those dates. You got to be able to look at the diagram and pick which date it is, and you've got to use those names that we have over to the side here. Equinox, solstice, spring, fall, all of those names for the days and the dates. You got to have both of those in your brain. Now, when you're zooming in on that side view, the key things are knowing where does the direct rays strike and being able to pick out what the date is again. So the first day of summer, June 21st, summer solstice, hits up here, Tropic of Cancer. Now you don't have to actually memorize that word. That's the one thing that we can find in the ESRT, kind of indirectly. Look at that little rhyme. Tropic of Cancer is 23.5 degrees north. That's great, buddy. I'm doing a little video over here, okay? So I'll check out that big puzzle later. I'm doing a little video with Yuri here, okay? Can you say hi? Yell a big hi. No? Okay. So, Tropic of Cancer. You don't have to memorize the name of that line. The tilt of the Earth is 23.5 degrees. So, okay, buddy, I got to do this video. I need you to be a little quiet, okay? Thank you. The tilt of the Earth is 23.5 degrees, so Tropic of Cancer, that's as far north as those direct rays get. That is why that's the Tropic of Cancer. The equator, the direct rays hit on the equinoxes. March 21st, September 21st, they hit directly in the middle here. Tropic of Capricorn is where the direct rays hit. This is the strongest sun on December 21st. First day of winter for us, winter solstice. Now if we turn this diagram this way, this is going to show where do the direct rays hit, okay? And the direct ray is coming straight down. That's what it means to be a direct ray. So you got to know where they hit, which times of the year they hit, where would the sun be striking directly in different months, okay? And then the side view was what we just looked at. Now the top view is a little more difficult, but you're still focused on the same 2 things. Those 2 things, okay? The North Pole, you're always trying to find the North Pole in the diagram, and the sun. So now it's like you're out in space looking down on the Earth from the top. If you can zoom in on that right there, you see how the North Pole is directly straight up and down? It's splitting the dark and the light. Okay, so that's the first day of spring or fall. The North Pole is tilted towards the sun there. That's the first day of summer. You can't really see it how I drew it there, but see if I can do it. Right there in the darkness is the North Pole. It's pointing away from the sun. Okay. One other thing to remember, the Earth is revolving around the sun. The Earth is also spinning, and we will talk more about what it means to be daytime and nighttime in an Earth's rotation and revolution video. Okay, so finding the North Pole and finding the sun and figuring out is it pointing towards, away, or is it neutral? Okay, and then you'll see some diagrams that look like this. Okay, this has a little bit more of the facts and a decent amount going on. It's not always filled up with all of this information, but you've got the same thing. So you've got to be able to label, what's the date? This is June 21st, North Pole tilted towards the sun. This is March 21st, December 21st, North Pole tilted away. In between, you might have to label. The kind of question would be like, put an X on the Earth's orbit. It was tough looking at it from reverse. Put an X on the Earth's orbit during July, during August. Put an X where the Earth would be in its orbit around the sun in October. And you've got to pick. Okay, picking back up here. So you're going to have to pick out, where on the orbit might the Earth be during a certain time of year. So if this is September, the Earth is going here, October, November, December, January, February, March. So as the Earth is revolving around the sun, it is at different places, different times of the year. It goes around the sun. It takes 365 days to go that 360-degree circle. We'll talk more about in a separate video the speed of rotation and speed of revolution, but that's a 365-day. You know this. You've lived on Earth for like 15, 16, 17 years. Other things. Perihelion, aphelion. Aphelion is away. This is the furthest away that the Earth is from the sun. June 21st. Okay? This is about the time that we get the furthest away from the sun. It's a little bit after June 21st, but we are furthest away here, and we're closest here. So we're actually further from the sun in our summer. So you got to know aphelion. That's when we're moving the slowest. The further away two objects are, the slower the object orbits. So the Earth is going slower here. It's further away here. And the gravity is the least over here. Okay. And the sun would look a little bit smaller in the sky in June, and it looks a little bit bigger in December because we're closer. Okay. The sun looks larger. The sun's closer, so we're moving a little bit faster, and that's called perihelion. That's when we're closest. Those are some different things about the orbits and being able to pick out where is the Earth in its orbit different times of the year. So let's look at some of those questions for that, and we'll edit out all that crying that you did earlier, Yuri. Okay? Okay, what position of Earth represents the first day of summer in the northern hemisphere? So let's circle this. I put everything on one page here to make it easier. This is a diagram that they gave for all three of these questions. So looking at this diagram, they wanted you to answer questions 100 through 102. There's actually only 85 on the test. Those are numbers from my questions. So what position of Earth represents the first day of summer? See if you can pick that out here. Okay, the key thing I'm looking for is where is the North Pole? Here's the North Pole in each of these positions. Okay, the North Pole is tilted away from the sun here. First day of summer would be C. Diagram below shows how the Earth is illuminated by the sun. Now the sun could be on the left, the sun could be on the right in any diagram. You've got to say, where's the sun? The sun's over here in this diagram. The North Pole is right here. The North Pole is not tilted towards the sun. It's all in the darkness. Since it's completely in the darkness, that would go with position A. So it's a very hard concept, but you've got to put yourself in the diagram. You're looking at it from above, and you can see that that North Pole is completely in the darkness. So this question would be A. How many degrees will the sun's vertical rays shift on Earth as it goes from C to D? C to D. That's one season. Each season, it changes whatever the tilt of the Earth is. So the sun is tilted 23.5 degrees. So the Earth, did I say the sun's tilted 23.5? The Earth is tilted 23.5 degrees. So that's how much it changes each season. A couple of things that we kind of forgot. That'll probably be my go back to, this is what you forgot, old man thing at the end of the video. If the Earth was tilted more, there'd be stronger seasons, more drastic change. And if the Earth was tilted less, the seasons would be less dramatic. And if the Earth wasn't tilted at all, that'd be the cat's pajamas, because it'd be like the fall year-round. All right, so you can ignore the halves. This is how I drew the diagram here to show the sun and the Earth. Okay, so this is the Earth. It's half lit because the side facing the sun's always lit. We're looking at it from the top. Okay, so if I draw some north poles, just so we can go over this one more time, that would be March 21st or September 21st, spring equinox, fall equinox. This right here, summertime, would be tilted towards the sun. Winter time is tilted away from the sun. Hopefully that makes sense. It's a top view. It's a less common used way of drawing the Earth-Sun relationship, so I'd like to go over it a little bit more. All right, so this gets a little more confusing because once you're at the end of the year, you've already studied the moon too. And if you look at this diagram, you've got the Earth, and you've got the moon, and you've got the sun. Here's the North Pole labeled for us. What's one season that begins when the line separating the day and night? The season that begins is either going to be spring or fall. So this is a short answer question. You would write down spring or fall. Some top view diagrams. Which season in the northern hemisphere is the northern hemisphere experiencing at E? It's a little more difficult here. Okay. First, pick the 4 dates. Can you find June 21st? June 21st would be right here at B. Okay. So 3 months later, remember June, July, August, September, October, November, December, North Pole's tilted away. This would be in about January. January is in the winter time. So between D and A would be winter. Okay. First day of spring between A and B would be springtime. First day of summer, I guess we got to put a little SP. First day of summer is here, so this is summertime. Another one, you're always looking, where's the sun? Where's the North Pole? Since we're on this and I have color drawings, you won't have a colored pencil in the final exam, but it's always good to label where's the North Pole. So tilted towards the sun, what season is just beginning? Summertime. What's the date? June 21st. What's the name of the day? Summer solstice. Got another diagram here. It's a little bit exaggerated, goes through some of those things, and it gives us, usually these are words that they give you and you don't have to come up with on your own. Just remember, A, away. And you can see that it's exaggerated. It's further away when it's tilted towards the sun. Describe the change that takes place on the size of the sun as it moves from perihelion to aphelion. As we're getting closer, it would get bigger. As we're getting further A away, the size of the sun's going to look smaller. So anytime you're doing a relationship, let's start picking over here. As you put the first thing, what's the first thing? As Earth's distance increases, the sun and Earth's orbital velocity. As the distance increases, it's the first thing. The second thing is Earth's velocity. What's the Earth's speed do? As you get further away, the further away two objects are, velocity is going to decrease. So I like to write it out in order, just the way. I'm going to move this one up here. The first thing, let's even underline those. Okay, so I like to write it out in order. You take the first thing, as Earth's distance goes up, and you take the second thing, orbital velocity, and you put the second thing there, and you just have to pick, does it go up or down? Identify the season in the northern hemisphere at perihelion. I look at that North Pole, tilt it away. It's the first day of winter, so winter season. Similar diagram. Describe the change that takes place in the gravitational attraction as the Earth moves from perihelion to away. So there's going to be less gravity. Gravity decreases. Gravity goes down, anything like that. Another diagram here. How many days does it take to travel from B to C? That's an interesting one. Well, the whole orbit takes 365. Okay. So there's 4 seasons. Each of these is going to be 1/4 of that. Hey Siri, what's 365 divided by 4?
The answer is 91.25.
That's what I would write that down, 91.25. They would probably take somewhere between 91 and 91.5, I'm guessing, but be as accurate as you can. In the northern hemisphere, during which season does the Earth reach its greatest distance from the sun? This one is not off of a diagram. So, when is it further away from the sun? In the summer. They actually had you pull that out of your brain, which is more rare. Usually they give you that diagram to work with. Yeah, Yuri, old man Spado forgot to mention one important thing. So, the Earth is tilted 23.5 degrees. So that's the tilt of the Earth. That's why we have seasons. That's the whole reason for season, the tilt of the Earth. It has nothing to do with anything else. The Earth's tilted, we have seasons. If the Earth was tilted more, our seasons would be more drastic. Summers would be even warmer, and winters would be even cooler. Now, what would be the cat's pajamas if the Earth wasn't tilted at all? Then it would be fall, year-round. There'd be no seasons if there was no tilt, and Mr. Spado would be a happy old man. Right, Yuri? You don't care if there's seasons? Doesn't make any sense to me.
My favorite season's the summer. I like to go to the beach and swim.